Hello everyone, welcome to my YouTube channel. Today I'm solving the Leetcode question 1905, count sum of islands. So this problem is going to be solved using depth first search, DFS. So this problem is also very similar to some of the DFS problem we already solved. For example, the very classic number of islands. So let's first take a look at the problem statement. So you are given two m times n binary matrices, grade 1 and grade 2. They contain only zeros. 0 means water, and 1 means land. An island is a group of ones connected four-directionally, horizontally or vertically. Any cell outside of the grid are considered water. An island in grade 2 is considered a sub-island if there is an island in grade 1 that contains all the cells that make up this island in grade 2. So we want to return the number of islands in grade 2 that are considered sub-islands. So the problem statement is very complicated. So let's try to understand the problem a little bit better by walking through this example. So we have two grades. So the grade on the left is the grade 1, and then the grade on the right is the grade 2. So in each grade, 0 represents water and 1 represents land. So basically you can form an island if you have a group of ones that connected four-directionally. Let's say in this case, so the highlighted cells, those cells highlighted in yellow are actually forming the island. So there are three islands in grade 1. So because those ones are actually connected four-directionally, which means they're either connected up, down, to the left, or to the right. So that's kind of how the islands are formed. So, and then now let's take a look at the sub-island. So the island in grade 2 is considered sub-island if there is an island in grade 1 that contains all the cells that make up this island in grade 2. So in this case, the island highlighted in red in the grade 2 are actually the sub-island of grade 1. So let's take a look at them one by one. So in the first ones, so compare this shape with the island in grade 1, we will see that, okay, the island in grade 1 actually have one more cell, one more land cell compared to the sub-island. So this one, the red sub-island in the grade 2 is actually a valid sub-island. So the standalone island in the grade 2 in the middle, where my cursor is actually not a valid sub-island. Why? Because let's look at the corresponding cell in the grade 1. So for the same row and column index, this corresponding cell has a value 0, which means it's water in grade 1. So that's why this standalone island in the grade 2 is not a valid sub-island. Then let's take a look at these two islands. So these two islands that are highlighted in red, each of them is a standalone island itself in grade 2. And then there are the valid sub-island in grade 1 because we can find an island in the grade 1 that's actually contain all the components or all the cells for each island. So that's why these two are valid sub-islands. So now let's take a look at the last island in this grade 2. So this kind of like L-shaped. So there are three cells in this island. However, they are not the valid sub-island in grade 1 because we cannot find the island of equal size or bigger size that's kind of like entirely contain these three. So that's kind of how we get the number of valid sub-islands. So in this case, the output should be 3. Let's take a look at another example. So in this one, given the two grades, grade 1, grade 2, so the output should be 2, just those two, one on the lower left corner and then the other one on the lower right corner. So you probably ask, okay, so what? The second row seems like the overlap between the two grades. Why this piece is not a sub-island. It is not, because this this second row itself is not an island itself. It's part of island in the grade 2. So it's not the entire island in grade 2. It's part of the island in grade 2. So even though this entire island, so this pie-shaped, the Greek letter pie-shaped is is an island itself. So the second row is just part of this entire island. So that's why even though these two kind of have a lot of overlap, still this island is not a valid sub-island in grade 1. Cool, so now let's think about how we solve it. So we can solve it utilizing depth-first search by traverse through all the island in grade 2 and then check if an island in grade 2 is actually part of the island or if it's a sub-island in grade 1. So in that case, how do we start the traversal? We only start traversal if we can find the island cell that belongs to the grade 2 and then it's also an island cell in grade 1. Why? Because it's not an island cell in grade 1, which means like, okay, we find a land cell in grade 2, and then the corresponding cell in grade 1 is actually water. So we know that, okay, any island this cell belongs to in the grade 2 cannot be the sub-island. So in that case, there is no point to start traversal over there. So, okay, so within the DFS, how do we want to traverse through all the cells belong to the same island? Let's say we start our traversal here because both of the cells in grade 1 and grade 2 are are island. So in this case, we will traverse, let's try to traverse through this entire island in grade 2. If we ever hit a boundary, we know we return, and then we are not keeping traversal in that direction. And then when we traverse to a certain cell, let's say if we traverse to a cell and then the corresponding value for that cell in grade 1 is actually water. So in that case, we know this island is a not valid sub-island. So in that case, we just return false. And then we finish traverse this island. So now we discuss the high-level idea for solving it. So let's code it up. So first, let's get the dimensions. So the dimension for grade 1 and grade 2, they are the same. So we get M represent the number of rows and N represent the number of columns. It is kind of my habit to keep track to first start coding the main framework before coding the details for Dfs function. So we initialize a variable to track the total number of islands. So that's our valid sub-island in the grade 1. So we initialize the value to 0. And then we are trying to loop through the cells in grade 2. If that cell in grade 2 is a land cell, and then the corresponding cell in grade 1 is also a land cell, which means that, okay, start traversing the entire island from this point, from this this position, we could potentially form a valid sub-island. We start our DFS traversal. So in this case, it may be better to just keep track of, okay, so what is the state, whether or not it can form a valid sub-island. So in that case, as we discussed before, so if we can form a valid sub-island, then we return true. If we can't, we just return false. So when we return true, then that's when we update our counter. So after that, we just return the count. Okay, now let's code up the Dfs function. Define Dfs I, j. Okay, so now let's think about different scenario. What if it hit a water boundary or the grid cell boundary, which is also considered as water in this case? So in that case, we just simply return and traverse other adjacent cell. Or if we already visited. So here, for all the visited, we just mark it as values -1. So we keep track of the visited grid cell in place without utilizing any additional data structure. So here, it means hit boundary or grid boundary or island boundary. So why less than or equal to 0? Because I use grid value equals -1 to keep track of the visited. Cool. So that's one condition we consider. The other condition is, okay, what if the, okay, so sorry, one typo. It's actually in the grade 2. So, and then what if, let's say, the corresponding cell in grade 1 is actually water, so not the land cell. So in that case, we know that this island in grade 2 is actually not a valid sub-island. So in that case, we just return false. After that, we start visiting. So basically mark visited. So grade 2 I j, we mark this cell as visited, so we assign -1 to it. And then we are trying to visit the adjacent. So basically, we kind of go up, which is Dfs I -1 j. We go down equals Dfs I +1 j. We go to the left, Dfs I j -1. We go to the right, Dfs I j +1. And then we just return So if any of the adjacent grid cell is not a valid piece of the sub-island, in that case, that's why we want to return them in the AND condition. So here we finish coding. Let's try to run the code. Okay, wow, it's actually faster than 99%. So, okay, so let's take a look at the complexity. So what is the time complexity in this case? So the time complexity is just O m times n, because you visit each cell at most once. And then what is the space complexity? Here is O1. So because we keep track of the visited grade cell in grade 2 just in place by modifying the value in the original input grade without utilizing any additional data structure. So in that case, we did not utilizing any additional data structure like set or list or something like that. So in this case, our space complexity is just simply O1. So yeah, that's the end of this video. So if you like my video, please feel free to subscribe to my YouTube channel. I will post more videos for solving the coding problems. Thank you.